This is question 6 from the CCEA A2 Pure paper from 2022, and was a bit of partial fractions and a bit of binomial. So let's take a wee look. Write the following expression of partial fractions. So we're going to have this here equals a over 3 minus x plus b over 1 plus x plus c over 1 plus x squared. And note this is one of our repeated term ones, so we got to set it up then like that. So our common denominator then, we're going to times this one here by 1 plus x all squared. Some people leave out this wee line, but we'll put it in anyway. So it's a 1 plus x all squared, 3 minus x, 1 plus x all squared. I'm sort of regretting it now. B upon 3 minus x and 1 plus x. Again, the same denominator here, 3 minus x, 1 plus x all squared, plus c upon 3 minus x all over 3 minus x, 1 plus x all squared. So we're going to equate that. I have an equal sign there, which means it's equal to this. And we're going to join those together, and it gives us the same top line. So I think most people are comfortable enough with the fact my next line is going to be x plus 5 equals a 1 plus x squared plus b upon 3 minus x 1 plus x plus c upon 3 minus x, and we got to work out what a, b and c are. So I think our first obvious one is to let x equal to 3. X is 3, that gives me 8. 1 plus 3 is 4, so it's going to be 16, and that disappears, and that disappears, so that means a is a half. Whenever we put x equal to minus 1, then we get 4. That disappears, and we have that is 4c. That gives me c equals 1. And then some people struggle with this, but we're going to equate x squared terms. So there's no x squared term here, so that's going to be a 0. There's going to be an ax squared. There's going to be an a there, and then there's going to be a minus b. Putting in a equals a half, so a half, take away half is that, and then we have b equal to a half then as well. So we're pretty much there. Our original question, x plus 5 over 3 minus x upon 1 plus x squared equals a over 3 minus x. Now remember, it's a half up here, so we normally bring that half and integrate it down below rather than having a fraction within a fraction. So it's 2 upon 3 minus x. B is a half, so it's 1 over 2 upon 1 plus x plus 1 over 1 plus x all squared. On then to part B. Hence, using the binomial theorem, expand this in ascending powers of x up to and including the term in x squared. So there's a wee bit to do here. So let's take a wee look. So we have rewritten this, and we're going to rewrite it then for what we worked out in part 1. So that's 1 over 2 upon 3 minus x plus 1 over 2 upon 1 plus x plus 1 over 1 plus x all squared. And so we need to take each of these in turn and expand them out. So there's a bit of work in this, but let's see where we go. So let's take the first bit here. So 1 over 2 upon 3 minus x. We need to rewrite this kind of in a form we like. So it's going to be a half upon 3 minus x to the minus 1. And remember, in our binomial theorem here for A2, if this is a negative power, this has to be a 1. That's the way the formula is set up. So we need to kind of rejig this very slightly. So that's going to be a half upon, let me see, 3 upon 1 minus x over 3 all to the power of minus 1. And what's that going to give me? 3 to the power of minus 1 is 1 over 3. So it's 1 over 3 times 1 over 2. So that's a sixth upon 1 minus x over 3 to the minus 1. And that's then the thing I'm going to be expanding out. So I have this here, 1 over 6 upon 1 minus x over 3 to minus 1. And in the binomial formula, it's just straight from your booklet, from your formula booklet. Anytime I see an x, I'm going to exchange it for a minus x over 3. And anytime I see an n, I'm going to exchange it for a minus 1. So it's going to be a sixth upon 1 plus nx minus 1 minus x over 3 plus minus 1 minus 2 over 2 factorial minus x over 3 all squared. And that gives me, let me run out of space here, a sixth upon 1. The 2 minuses cancel, so it's plus x over 3. And then here, those minuses cancel and those minuses cancel, so this is going to be a plus. Minus 1 times minus 2 gives me 2 over 2 factorial, so that all cancels. And then we have this, the minuses cancel, so I get x squared over 9. Now the other ones are a little bit more straightforward to expand out, so let's look then at my second term. So that's that one. This one here, we can rewrite that then as a half 1 plus x to the minus 1. Anytime I see an n, I exchange it for minus 1, and x then just goes to x. So not quite as much going on here. Still need the half out the front. It's equal to half 1 plus nx plus minus 1 minus 2 factorial x squared. That gives me a half. Really running tight for space here, I need to tighten this up. 1 minus x plus, I think that all cancels, x squared. The final one then is this one here. So bringing this up to the top, it's 1 plus x all to the power minus 2. Anytime I see an x, I'm exchanging it for an x. Anytime I then see an n, I exchange it then for a minus 2. So that gives me 1 plus minus 2 upon x plus minus 2 minus 3 2 factorial x squared. And if we tidy that up, see if I can fit it all into one line. 1 minus 2x, 2 times minus 2 times minus 3 gives me positive 6 over 2 is 3, so it's 3x squared. We then need to join all three of those together. Do you see the three things that I have? It's going to be this one here, and this one here, and this one here, and we're adding them. So therefore expansion is a sixth upon 1 plus x over 3 plus x squared over 9 plus this one here, a half upon 1 minus x plus x squared plus this one here, 1 minus 2x plus 3x squared. This is messy enough. I'm not going to go through it all, but that's in terms of our numbers. So let's see what I have in terms of a number here. This is a sixth plus a half. So a sixth plus a half, I think then is 4/6, so that's 2/3 plus 1, so that becomes then 5 over 3. This here, that's x over 18, that's minus x over 2, and that's minus 2x. You can take my word for it, it gives you minus 22 over 9x. We're just joining together our like terms here. And then our x squared terms, this is messy too, so it's a sixth upon x squared over 9, so that's x squared over 54, plus x squared over 2 plus 3x squared, and that gives plus 95 over 27 x squared, and that's that one done.